Hello everyone, this is Randy again, back in the shop today. Today starting a new engine build. It is starting out with a Dart Little M Sportsman block, and it's going to be 4-inch 125 bore with a 3-inch 330 stroke, so it makes it 357 cubic inches. Uses a Brodex 18-degree head, solid roller cam. It's a Sonny Bryant crankshaft, Carrillo rods, flat top piston. It's going to be 12.8, 12.9 to 1 compression. The motor had dropped the valve. What had happened is the roller had fallen out of one of the roller rockers and beat on the valve spring retainer, and it eventually knocked the keepers out of it, dropped the valve, and the destruction was on. One chamber and a head was completely destroyed. Sent pictures of that to Brodex, and I talked to them, and they said they could fix it. So I sent the head to Brodex, and they repaired the head, put new seats into one head and a couple of guides, and the head looks just like brand new. Let me get this rocker here and I'll show you what happened when the roller fell out. Be right back. This is the rockers that were on number one cylinder. They're on like this here. They go on the cylinder head like that. And this roller had come out, and you can see how bad it beat up on the retainer and the keepers. And finally the keepers popped out and valve drops in the cylinder, and it's all destruction after that. Was trying to get a aluminum block to put this thing back together with, and aluminum blocks nowadays are they're unobtainium. They're just not available, and he got tired of waiting, so we decided to put it back together with a steel block, Dart Little M Sportsman block. Yeah, it's a little heavier, about 50 pounds heavier than the aluminum block, but that's the only disadvantage I can see, is the weight. You don't have the expansion problems with an aluminum block, with a steel block, that you do with aluminum block. A steel block, when cylinders are finished properly and everything, a motor with an iron block will actually make more power, just because the fact that everything doesn't grow and change shape and everything else. You don't have problems with main bearing clearance, growing too much and all that. The crankshaft, bring it over to the lathe here a minute. I got the crankshaft set up to inspect that. The crankshaft is a Sonny Bryant crank. Really nice piece. It is 3-inch 330 stroke, small General Chevy connecting rods and mains, and you cannot buy a replacement block that uses small General mains, so they all come with 350 main. And Federal Mogul makes a bearing that for that, but they only offer it one size, So if your crankshaft is a little undersized or oversized, you're pretty much limited that way with bearings. I'll bring it over to the block here. So what I did is put a stock set of 350 main bearings in, and then we line bored the block to put early small journal Chevy bearings in, because those there are readily available, and you can buy them in like a 1 under or 1 over. They're readily available. This is kind of the same type of process that we went through on the stock 400 block build that I'm working on at the moment. The problem is, I'll bring over to the bench here. Let me pull this bearing out of the block here, and I'll bring it over to the bench and I'll explain what's going on. Be right back. Okay, back over at the bench here with these bearings. The block is machined for this tang right here, which locates the bearing, centers the bearing in the main journal in the block. The problem is the early 327 mains. Just a minute. Okay, I'm back. The dog had his ball trapped. He couldn't get to it. They got this tang here on the edge of the 350 bearing. On the 327 bearing, the tang is wider, and it's actually on the opposite side, so when you put it in, it won't fit the spacers that I made. So what I have to do is put this on the mill and use a woodruff key cutter and cut a slot in the edge of the bearing right here. I already got a couple done. I'll go grab one here. I'll be right back and I'll show you what that looks like. This is one of the bearings that I have done, and you can see I had to machine this slot here for the relief for the tang, so that this bearing will sit in place like such, just like that. So that's what I'm working on today here. I'll bring you over to the mill and I'll set this bearing up. I kind of made a fixture with just some blocks and clamps and stuff, and I'm holding these holding this on the mill table flat like this here and clamping it down, and then I'm machining that groove. So I'll bring it over to the mill, we'll set this up, and I'll show you how this works. Be right back. All right, back over at the mill here. Here's my kind of a setup I got here. I put the bearing in like this here. Got this block clamped to this 246 block, and got this that I set on top of here like that, and then I put a clamp on it, a hold down clamp. Like that. Sorry about having my hand in the way here. I kind of have no choice. Start a nut on this hold down stud here. And then I take a square around the back side, push it up to make sure that the bearing is square, like such. I got a block on the back side here, so I make sure that that's square, that the bearing is tight up against the block there, and I push it down with the square to make sure that it's square. Tighten my hold down clamp down. Don't want to tighten it real tight, but you want it just tight enough so it holds it, so it doesn't move. Check this again, make sure this is square still. Yep, we're good there. So that's how I'm holding the bearings to cut them. I'm going to move the camera around the other side so you can see, and be right back. Okay, I got to move my table back in position here. Got the numbers on the DRO, so all I do is go to 0 on the x-axis here, and that will give me the proper depth into the bearing that I'm centered on the cutter. Right there. And as you can see, the bearing is right here, right there. There's my woodruff cutter, and we'll crank this in a little bit here. Start to mill. Just touched. Start bringing it in real slow. Feeding it in really slow. That way the cutter doesn't grab that shell and pull it out of position. Got 30 thousandths to go. Looking at the DRO here. All right. That's that. Feed this back away from the cutter. Shut this off. All right. Pull this bearing out of the fixture here. Loosen this up. there you have the groove machined in there for the tang. I'll take a file and I'll deburr this edge right here and bring it right back. Okay, back on the bench here. Get my file and just lightly file this here just to break the burrs. I'll bring it over to the block and we'll put it in. Be right back. Okay, back over at the block here. Put this one bearing shell in here, my spacer, and we'll put the upper main bearing in. Now that fits just like that. Let me get a different block here. So the block across here, we make sure that's seated good. Yep. And the bearing tang, just a little bit of clearance right in here. It's got about probably 10 thousandths gap between the tang of the actual bearing and the shell that was put in the block, and the block was line bored with. I have to do the uppers the same. It's the same thing with the upper, so I'll do them and I'll bring it back when I got those finished. Be right back. All right, I'm back. Finished the last bearing shell up. As you can see, the relief is cut into the shell here for the bearing tang. Slide this in here, just like this here. already deburred the edge. Slide that in there. Perfect fit, just like it's supposed to be. Now I can put these bearings in the block and torque them up, and we'll check, see how much clearance we have on the crankshaft on the mains. I got to mic all the mains on the crank and then set the dial bore gauge up for each individual main journal and run the bore gauge down through the main to check the clearance. This is just some of the stuff that you have to go through building a motor. People buy parts and they complain because it doesn't fit and everything else. Well, when you buy all aftermarket parts, the parts are supposed to fit, and maybe they fit, but not always. That's why you have to check everything. So hope you enjoyed that, and we'll see you in the next video. Have a great day, and also a Merry Christmas.